Okay, in case you missed it or you need to re-listen, these are the notes for 1.4 for period 1, because remember we skipped 1.3. So more review, or more radicals. These are perfect squares you want to look for, but now we're going to have extra variables in here. So you want to think about when you have a variable, excuse my reach, sorry, that x to the 4th power means x times itself 4 times, and y to the 6th power means times itself 6 times. 1, 2, 3, 4, 5, 6. So when you take the square root, you're trying to find pairs. So I have a pair of x's, and I actually have 3 pairs of y's. And so everything is circled. Everything that's circled goes out. When you take it, you multiply. X times x is x squared, and y times y times y is y to the 3rd. Nothing is left inside. Now you don't have to write this out completely all the time, but basically that's what you're doing. These were both even, so they went in evenly and they were fine. If you look at this one, we got an x to the 5th and y to the 9th. I need to find pairs. Well, there's a pair, 2 pairs, but you have an extra one over because it's an odd amount. You can't make an even amount of pairs. And with the y to the 9th, you're going to make 4 pairs. And you have an extra one. So all the extra ones are going to go inside. So it'd be x squared, 1, 2, 3, 4 pairs of y, and on the inside would be an xy. So you notice that anything left over is still inside the radical. And now when we're doing inside the radical, we're looking, if it's an odd number and we're taking the square root, we're going to have one left. And this is never going to be higher than a degree 1. This one I had you guys try today. Again, this answer was 6x squared because 36 is 6 times 6, and you can make 2 pairs of x's. Where this one's a little bit harder because you have an odd number and you can't take the perfect square root of that. So I did 4 times 6 today, which is 2 times 2. 6 can break down to 2 and 3, but there's not going to be any matches. X to the 7th, I can make 1, 2, 3 pairs out of 7 and 1 left over. So the things that are underlined are going to be left over. So 2x to the 3rd, because 3 groups of x's, 6x. So as we're going down, we're going to get harder problems, and then we're going to get cube roots and 4th roots, which are going to make it a little bit different. So now these have a number on the outside. Whatever you take out, that's going to go on the outside and multiply by that. So don't worry about that yet. Just still worry about this part, 24, just like the last question. X to the 5th is just like kind of like the last question almost. You can make 2 pairs. And y squared, you can make a pair. So everything circled is going to go on the outside. There's already a 2x on the outside, and then we're going to take another 2x squared y, the stuff circled, and what's left in is 6x. Well, we don't leave it like that. We want to simplify it. So it'd be 4x to the 3rd, because remember we multiply, we add exponents, y, and then the square root of 6x. So I'm hoping if you guys watch the video that it will help you if you missed anything today. Same thing on the next one. We're not going to worry about that. We're going to break down this. This is 16 times 3, which is 4 times 4. The 3 is going to be left in. And if I have 5 x's, I can make 2 pairs and 1 left. And if I have 3 y's, I can make 1 pair and 1 left. So again, if it's odd amount, then you're going to have something left inside. So everything that's circled is going to multiply by what's out here. So 4 times 2 is 8. X, 2 x's with another x is x to the 3rd. And then y. And left inside would be 3xy. So make sure that you go back and you look at all your circled things, all your underlined. You didn't forget something somewhere. You got to kind of have to be neat on these and make sure you have everything. Okay, so the next ones are going to have some cube roots in them. That means we're looking for 3 of things. So when we do the 8, that's 4 times 2 and 2 times 2. So we have a group of 3 2's. And then x to the 6, I can make a group of 3. I can actually make 2 groups of 3. Okay, so you might start noticing that you're really just dividing the power by the root. So everything is circled, so our answer would be 2x squared. So the next one, 16 is 4 times 4, 2 times 2 times 2. Okay, I need groups of 3 because it's a cube root. So I have 1 left over. X the 5th. I can make 1 group, but you got 2 left over. Basically because 3 goes into 5 one time with the remainder of 2. And Y the 9th. You can actually make 3. So you notice it divides evenly. That's why they're all circled. So everything that's circled is going to go on the outside. So a group of 2's, a group of X, and 3 groups of Y's. And everything that's underlined, and don't forget the little 3 for cube root, is going to go inside. And there's 2 X's left over, that's why there's an X squared there. Try to put your root right there so you don't forget it. Same thing on this one. You can break it down 500 however you want. So I think in class I broke it down to 5 times 100, 5 times 20, and then I have to keep going. So if you notice, we have a group of 5. We can break down the 4 and 2 and 2, but I know there's not going to be a 3 of those. And this is going to be negative. Now x squared I can't make 3 because that's smaller than that, so there's no way. Y to the 5th, a group of 3, so these are going to be underlined. And z to the 3rd, I can make a group of 3's. So your answer should be negative 5, no x's because we couldn't take any out, y, z, then the cube root, we have left a 4, x squared, y squared. Again, if you kind of start thinking you're dividing these in, if this is smaller than 3, it won't divide evenly. And then 4th root means we were looking for groups of 4. So 81 is 9 times 9. 3 times 3 times 3. I got a group of 4. X the 4th, yeah, that's a group of 4 already. And y to the 5th, you can make 1 group of 4 and you have 1 left over. So the only thing that's left over is that y. So we write the answer as 3xy, 4th root of y. Okay, so now we're going to talk about multiplying. So I'm going to go to the next page. And so this is the important part from today. You can, anytime you're multiplying two, you can write them inside together. I'm not going to really worry about this too much. But if you have a coefficient, outside numbers can multiply by outside numbers and inside numbers can multiply by inside numbers. And then you're going to simplify. So you could write this as the square root of 18 and simplify it like yesterday, because we actually had this example yesterday. Or you could leave this as 3 times 6, break down your 6 as 3 times 2, and now write that as 3 radical 2. Either way is fine. I like to not multiply it out unless I see it's a perfect square, so that I don't have to break down big numbers in a factor tree. So like on this one, outside numbers multiply by the outside numbers, inside numbers multiply by the inside numbers. But I'm not going to make that 50, I'm going to leave it out like that and then break this down. Then I notice that these match and I can match those. So when I match those, I'm going to take that outside, multiply it by the 6. Remember, it's all multiplication. The 2 is left in. This is the one I had you guys try in class. It looked like this. The 6's match. And it was 48 radical 2. Now we're going to do the same thing with variables. So we're kind of putting in what we did on the first page plus the multiplication and kind of do it. And so this is what I do. I leave the numbers separate because I don't want to multiply, but I actually do combine these. That's x to the 4th. So I'm going to write 4 x's. Now it's a square root, so I'm looking for pairs. I'm going to break this down to 2 times 6, 2 times 3. I see a pair of 2's, but these don't match. And then I have a pair of x's, 2 pairs of x's actually I can write in there. So again, everything that's circled is going to go on the outside. So 2x squared goes on the outside. What's left is the 6 inside. Okay, same thing on this. This one I might actually multiply. So why not? That's 36, which I know is 6 times 6. And that's x to the ninth. You can write x to the ninth if you want, or you can write out your x's. It's up to you. 1, 2, 3, 4, 5, 6, 7, 8, 9. I need to make pairs. You should know that I can make 4 pairs and 1 left over. So your answer is 6x to the 4th x. And this is the one I had you guys try in class today, but you guys did awesome. I'm going to just write it out again. This is what I did. I did 8 times 4. I did x to the 5th, y to the 11th, I broke down the 8, it's 2 times 4, and I didn't have to keep going because I had a pair. And then 1, 2 x's, 1 left over, 1, 2, 3, 4, 5, 1 left over. And so our answer was 4x squared y to the 5th square root of 2xy. So you gotta again be neat and make sure that you can see everything that's circled and everything that's underlined. That's why I go through and I underline everything so I don't forget anything. Okay, next page of note is dividing. There is a rule in math that you cannot have a radical in the bottom of the denominator. It's all because we can't add and subtract fractions unless they have a common denominator. So this is kind of your helpers. Check for perfect squares. See if there's anything you can take the square root. Check if you can reduce any of the fractions, and then rationalize. And I'll talk about what rationalizing is in a second. And then at the end, see if you can reduce again. So rationalizing means to get rid of this radical, and the big rule of thumb is you just take whatever that radical is after you've done the first two, and you multiply the top and bottom by that. And so this right here is 1. Something divided by itself is 1. So all I'm doing is changing and multiply by 1. And now I'm going to multiply across. So remember, you can only multiply numbers inside with inside, outside with outside, but these match. So the 7 comes out. I know it doesn't look any better, but it's rationalized, so now you can get a common denominator easier. Same thing on the next one. There's a bottom root of 11, so we're going to multiply the top and bottom by 11 over 11, which is 1. Again, this number's outside, so it doesn't multiply by that 11. These 11 match. The square root is going to be just 11. Now we looked for perfect squares, there weren't any. We looked for reducing, there wasn't any. We rationalized. Now we check if we can reduce. 3 and 11 don't reduce. You can only reduce numbers on the outside, not inside the radical. And so you're done. So a thing I would do on the next one is I check for perfect squares. It's not. Let's see if I can reduce. This is a division problem. 18 divided by 2, I can divide those because they're both inside. That's just 9. And I know the square root of 9 is 3. There are other ways to do that question, but that's by far the easiest way to do that problem. Where this one, I showed you guys 2 ways in class. You might want to check for perfect squares and say that's 5. Okay, might as well. See if you can reduce. Can't. This is outside, this is inside, so then you rationalize. So you take that root and you multiply by the top and bottom. This is outside, this is inside. A radical times a radical is just that number. And so I looked for perfect squares, I looked to reduce, I rationalized. Now I go back, can I reduce? Well, yeah, I can reduce that. That's 1/3, so I should get radical 15 over 3. 5 goes into 5 once, 5 goes into 15, 3. Okay, the next ones are written as fractions all inside. This means this. I preferably like to write it like this. Then I say, oh, I can rationalize this. Can't have a radical in the denominator. Now these are both inside. I can actually multiply them now. This is the first one I could do. The 5's match. I always look if I can reduce. Inside, outside, can't reduce, so I'm done. So if you look at the next one, I would want to reduce this before I start even rationalizing it, because why not? You can reduce. 5 goes into that 3, 5 goes into that 2. Then I would write this like this so that I know that they mean the same thing, and I'm going to rationalize it. Multiply the top and bottom by radical 2. Inside and inside, multiply. 2's match. I look if I could reduce it at the end. I can't. This is inside, this is outside. So that's my answer. Okay, so these last bottom ones are going to kind of put everything together. We're going to look to division, we're going to do with variables and everything. So again, I would look for perfect squares. I did this one a little bit different in class today, but I'm going to look for perfect square. 16, I can take the square root, that's 4. And I actually can take that. I should know that's m to the 6. I can make 3 pairs. So I can reduce that. This one I can't. Okay, I'm doing this totally different than what I did in class. I'll do it both ways. I'm going to simplify this still. That's 3 m's. I can take a pair left out. So I can write this simplified right now like this. Okay? I would multiply the top and bottom by 2 radical 2m. This is going to be messy. Actually, I'm not going to do it that way. I'm going to go back. I'm going to do it like the way I did in class today. I reduced in class. So 16 divided by 2 is 8. We haven't talked about this, but I know you did it last year. M to the third divided by m to the 6th divided by m to the third is m to the third. Remember, you have 6 m's on the top, 3 on the bottom. You can cross cancel, you'd have 3 left. And now I can simplify that. I don't even have to rationalize because it doesn't have a denominator. That's not the answer, sorry. I can break down 8 to 4 times 2, 2 times 2, the 2's match, a pair of m's. These would be left, and so I'd get 2m radical 2m. Now I could have done it the other way and got the answer. It was just going to be a mess. It's easier if I would have reduced to begin with. Okay, last one. I want to look if there's any perfect squares. There's a couple things I could do. I could actually simplify 12 if I wanted to, but I can leave it also. I can, because it actually does have a perfect square in it. And these don't simplify. 3 and 4 don't simplify, 12 and 7. So I'm just going to multiply the top and bottom by the square root of 7. So whatever that root in the bottom, you can multiply the top and bottom. So this is going to be 3 radical 84, because these are in multiply. 7's match, you're going to take it out, it's going to multiply by that 4. Okay, now you might think you're done. Because you're like, oh, 3 doesn't go into 28, but this is a big number that can actually be simplified into 4 times 21, 2 times 2. This is 7 times 3, but they don't match. So I'm actually going to take a 2 out, multiply by the 3 that's already there, and now, again, the last thing you want to do is reduce. So I noticed 2 and 28 are both divisible by 2. I mean 6 and 28. So I get 3 radical 21 over 14. Okay, and then we skipped the last page of 1.4 notes. We're going to save that to maybe later, something I might challenge with you guys later. But this is it. I hope this helps you if you guys were confused today.